Hey guys, this video is going to be a lesson/assignment where you are going to work on solving systems of equations by elimination. Review from our previous lesson because I know elimination is a little tough, so I'm breaking it over 2 days. And then substitution, which I think with linear equations at least, when you have two linear equations, is a little bit easier for some people. But with time, I think some of you might find elimination to be easier as well. So what I'm going to do before I start the actual worksheet that we have for today is I'm actually going to go back to the worksheet that we were working on yesterday, where we solved systems of equations by first graphing and then by elimination. We're going to look at that, do a little recap, go over those examples that we did for elimination, and then we'll move on. Okay? So yesterday, this was how we got our start, systems of equation by graphing and elimination, and we kind of reviewed the lessons that were relevant leading up to this point. We reviewed first, in the first lesson of this whole collection, what slope was. It's important you know slope is the change in y over the change in x, your rise over run, and we have a formula y2 minus y1 over x2 minus x1. Maybe keep that in mind. I'm not going over everything. It's just a little summary, okay? You might want to write this down if you don't have good notes. Then we went over graphing lines in slope-intercept form. And for that section, we focused predominantly on y equals mx plus b, which is slope-intercept form of a line. And the b is specifically, careful, make sure you know this, it is your y-intercept. The y-axis is the one that goes vertically up and down. In lesson 3, we worked with point slope form, which was y minus y sub 1 equals m times x minus x sub 1. On lesson 4, we talked about parallel and perpendicular lines, and just to get the nitty-gritty there, a parallel line, two parallel lines, they all, slope 1 will equal slope 2. The first line and the second line, they're going to be equivalent. Perpendicular lines, they are not equal. The way you write opposite reciprocal is we actually write M1 will equal the negative, which means opposite, reciprocal over M2. So example for that one, because that's weird for people, that notation, something like 2/3, the perpendicular slope will be negative 3 over 2, okay? Symbol for perpendicular is an upside down capital T, and for parallel, two lines like this. We're in lesson 5 right now. We're solving systems of equations. We should be able to answer the following questions. What are you finding when you solve a system of equations? You're finding the values for the unknown variables that will make both or all, because you could have more than two equations, both or all of your equations true. So if you have 3 unknowns, you'll have 3 variables. So maybe x, y, z, you'll have 3 equations, 3 variables, and you're going to find what combination of x, y, and z will make all 3 equations work. Visually, what are you finding? Where the two graphs intersect. So in a nutshell, that's what's going on. We kind of wrote that down yesterday. What are the 3 possible outcomes? The 3 possible outcomes were that we had one solution, at least for linear, or if the lines were parallel, we had no solution. Or if the lines were really the same line on top of itself, we had infinite solutions, okay? When you solve and it ends up being parallel lines, you might not notice right away. If you're not graphing, this will end up, as you're solving, with a false statement. So put a little note that you'll get a false statement, and this will end up giving you a true statement. What do I mean by that? 5 equals 2, and you're like, what? How do I solve? Okay, false. Probably no solutions, probably parallel lines. Maybe rearrange, put it in y equals mx plus b, check that slope, c. Same idea here, true statement, you're gonna get like 5 equals 5. You'll be like, where'd x go? What do I do? True statement, it's probably because it's the same line. Again, put them into y equals mx plus b form and see if they match. What are the 3 methods that we are using? Graphing, elimination, and substitution. So those are the 3 forms that we will be using. Again, we wrote that down yesterday. So you should all have that down in your notes. Next, I also had done examples 7 and 10 in a video yesterday. So I'm just going to redo example 7 for anyone who is riding the struggle bus. right over here, I'm just going to put that curly bracket in front, and that tells me that these two linear equations, which are more or less in standard form right now, are supposed to be on the same plane. And as long as they have different slopes, they're going to intersect eventually. To solve by elimination, you want to eliminate one of the variables, either x or y. I can do that by either making both of these coefficients in front of x, like they're already in the same order. That's important. So they're already written. I'm just going to write like this, like ax plus by equals c. They're both like that. That means all of your x stuff and all of your, well, I should really use like say dx plus ey equals f. A, B, and C could be positive, it could be negative, it really doesn't matter. But what we want to do is you either want A and D to be the same or opposite numbers, like 2 and 2, or 2 and negative 2, or you want B and E to be the same or opposite numbers. So you can maybe do 5 and 5, or 5 and negative 5, or negative 5 and 5. Couple options here. Now, once you have that, it makes it much easier to eliminate one of those letters. If they're both 5y, 5y positives, well, I'm going to subtract then my whole bottom equation from my whole top equation. 5y, take away 5y, gone. Y is no longer in the equation because we eliminated it, and we'll just deal with the x. All right? Or you eliminate the x's and we deal with the y's. Now, if I wanted to make both of these numbers the same, what can I turn them both into by just multiplying? You can't just add things to it. I can make them both a 20, but then I'd have to multiply the top equation by 4 and the bottom equation by 5, and they'll both have a negative 20 in front. And when they're both negative, it's usually a little harder for people because a negative and a negative eliminate if you subtract. I would avoid that. So instead of that, I don't want to multiply both equations. I'm embracing the 7y. I want to make this a negative 7y. That means I only have to multiply my second equation by negative 7, but everyone gets multiplied. Okay, next line, I'll have the first line's the same, negative 5x plus 7y equals 18. On bottom, I'm going to multiply by negative 7, again to everybody, like distribute to everybody. Negative 7 times negative 4, 28x. Negative 7 times negative y is plus 7y. No, I don't know why I did negative 7. That's fine. I think I did it differently yesterday. I think I just meant to do multiply by 7, but all good. I'll do it both ways. Let's go nuts. Negative 12 times negative 7 is going to be positive 84. I'm going to draw a line like it's an equation, a vertical equation. How do I make these eliminate? Well, they're both positive. I can't add them. I'll get 14y. That's not eliminating. So I'm going to put parentheses. I'm going to put a minus sign out front. If I subtract everyone from the bottom from the match on top, the same variable, the like term, I'm going to get a new equation. So I have negative 5x, go slow, minus 28x. Same sign, find sum, keep same sign. So negative 33x. 7y minus 7y. Eliminated. That better happen. That's the goal. Don't assume it happens. Make sure it happens. 18 minus 84. That's going to be 18 positive, 84 negative. I have a lot of negative and not a lot of positive. My answer is negative 66. Then you just finish off solving for x. How do I get x alone? The 33, negative 33 is attached with multiplication. We're going to divide by negative 33. And we get x equals negative over a negative 2. All you have to do from there, pick one equation. It doesn't matter. Usually I go for the one with the smaller numbers. So say here, negative 4x minus y is negative 12. You fill that you fill that x value into your equation. So we're going to go right over here and carefully fill it in. Negative 4 times 2 minus y is negative 12. And we're just going to solve for y. Once you have x and y, boom, you have an ordered pair, and that's your solution. Negative 8 minus y is negative 12. I'm going to add 8 to both sides. Don't lose the negative in front of that y. Negative y equals negative 12 plus 8 is negative 4. But I need a positive y. I need to know what y equals. So I'm just going to last step over here. I'm going to divide by negative 1. Sorry, it's a little squeezed in that spot there. And I get y is equal to positive 4. So now I have y equals 4 and x equals 2. So what's my solution? My answer, write it as an ordered pair, 2 comma 4 in parentheses. Now, I think what I did in yesterday's video, and I could do it on the side right now, is instead of multiplying by a negative 7, is I actually multiplied by positive 7, I'm pretty sure. But even if not, let's do it that way as well. If I leave that top equation still as negative 5x plus 7y equals 18. Now, what if I multiply by 7? That will give me a negative 28x. That will give me a minus 7y. And that also will give me a negative 84. Then, I want these to eliminate. If I subtract this whole equation, I'll have minus negative, which is plus, and I'll get 14y. Since they're already opposite signs, then you're just going to add straight down, but make sure you consider if things are positive or negative. So you'll just add straight down. What works better for you? Which way do you like to interpret things better? Now follow this all the way through. Negative 5 plus negative 28 is negative 33. You get the same answer, okay? Positive 7y plus negative 7y, eliminated. 18 plus negative 84, negative 66. I still divide by negative 33, and I still get that x is equal to positive 2. Again, you just go back, plug it in, and get the y, and you write the ordered pair, okay? So that is number 7. Now let's take a minute and look at number 10 from yesterday. Here's number 10 from yesterday. This time I want to eliminate, so I could either make both of these a 10 or a negative 10 and a 10, or maybe I can make just both of these a 4. This seems like a little bit less work if it's 4y and 4y. So I'm going to take my top equation, and you may choose to do it a little differently, and that's okay, but I'm going to multiply by 4. Let's see what happens. 4 times negative 2x. I'll get negative 8x plus 4 times y is just 4y equals 4 times negative 10 is negative 40. And again, they're already like in that order, ax, by equals c. Like you don't have to rearrange anything. If they weren't in that order, you might have to rearrange it because you want everything stacked above each other. And you want the equal sign stacked. You want the number by itself alone on the other side, whatever it needs to be. They should be stacked like this. This one I'm going to leave alone. 5x plus 4y equals negative 1. If I add these equations together, will I eliminate anything? No. In order to get rid of the y this time around, I need to subtract the whole entire bottom equation from the top equation. If it ever helps you and you want to flip-flop which one's on top or bottom, you could do that. That's allowed. If that makes it easier for you for some reason, you could do that. Now carefully. Negative 8x minus 5x. I'm already in a hole 8 feet deep and I'm going 5 feet deeper. Pretty deep now. How deep? Negative 13x. 4y minus 4y. Eliminated. You don't always have to eliminate the y. You can eliminate x. I just happen to choose that for these two. And then negative 40 minus negative 1. Minus negative is plus. So that becomes negative 40 plus 1, which will be negative 39. Divide both sides by negative 13. And we get x is equal to 3. Take that number and plug it in and get the y value. We're doing good. Negative 2x plus y is negative 10. Filling in that 3. That's negative 6 plus y is negative 10. Add 6 to both sides to get the y alone. Y equals, take your time, negative 10. You're negative 10 on the number line and you're going right 6 units. You're at negative 4 now. Final answer, or solution is the ordered pair 3, negative 4. So I hope this is helpful and able to get you guys to the right place. Let's see if we can get your assignment started though, so that you feel really confident. Or actually, no, that was enough for the assignment. I have to go over substitution. So silly. So your assignment, you're gonna have 2 examples right here. I just did 2 with you. So you're gonna do these 2 on your own, but you should, in your notebook, have copied those other 2, and then you're gonna do these 2. I have confidence in you. You got this now, okay? Even if it's not perfect, as long as it's pretty close, good enough for now, okay? I promise. Let's look at this over here. We're gonna solve by substitution. I'll do number 3 for you, and I'll do number 7 for you. But over here on this page, I want you to do, we're gonna do number 3 by substitution, 4 by substitution, 5 by substitution, and 7 by substitution. 6 and 8, you can pick substitution or elimination, okay? I'm gonna do number 3 right now. Then I'll also do number 7, okay? Number 3. Y equals this and y equals that. Substitution, well, what does this mean? Y is the same y in both of these equations. And apparently it's equal to negative 4x minus y, and it's equal to 4x plus 16. So what we're going to do is I'm going to take this second value of y. I have y alone. Y is that, 4x plus 16. And I'm going to substitute it in for y in the first equation. Okay? A lot of people like to say you're setting your equations equal to each other. Not really the best way to describe it, but if that's how you understand it right now, I guess it's okay. But I would refrain from using that because it doesn't always look like that. I subbed that in for that, negative 4x minus 8. And now all we do, we already eliminated y by substitution. Now we're going to solve for x. I'm going to add 4x to both sides. Eliminate some more, but not elimination. That's not what this is. That cancels out. Now combine like terms. And we get 8x plus 16 equals negative 8. Got to keep going to get x alone. I'm going to subtract 16 from both sides. And I'm going to have 8x equals negative 8 take away 16 is negative 24. 8 is attached by multiplication, so I'll divide to get rid of it. Sorry, I was cut off. I'll divide by 8, eliminate right there. That reduces or simplifies. I shouldn't say eliminate. I don't want to confuse you. Reduce. X equals, what's that? Negative 3. There's the x. Not done. Pick an equation and plug it in. Maybe you like the more positive equation. Y equals 4x plus 16. Plop in. It's kind of like another substitution, right? Negative 3. Then we get y equals, showing our work, negative 12 plus 16. And that means y equals positive 4. Final answer is negative 3, 4. And last thing I want to set you up, and I'm not going to fully solve it, but if you get something like this, you need to get a letter alone. I'm going to add y to both sides because I want my positive x alone. You want the positive number that has a 1 in front of it alone if you could get that. If you have to divide, then you have to divide, but I'd rather not. X is equal to 2 plus y. Since I have x alone, I'm going to take this guy and plug him in right there. 5x plus 5y is 0. If I fill that in, 2 plus y, and we just solve. Distribute the 5, 10 plus 5y equals 5y plus 5y, sorry, I think I said equals 0. Combine like terms, I get a 10y. I'm going to subtract 10 from both sides. 10y equals negative 10. Divide by 10. Y equals something. Take that number, fill it back in and get x, and write your ordered pair, which is x comma y for your final answer. I think you guys are going to be great at this worksheet. So finish this up. If you feel better about this stuff today, thumbs up. If you still are riding the struggle bus, thumbs down. Let me know and have a great day.